All right, so the last part of section 1.4, linear equations, I had two examples. The first one that I wanted to talk about is what happens with perpendicular lines. And then the last one is a specific type of perpendicular relationship. So if we're doing on problem number 9, the perpendicular lines, again, we're given a standard form of a line, and we would need to change that into slope-intercept so that we can see the slope more easily, right? So our goal is to put it into y equal mx plus b, just like our last problem. So we'll shift the x to the right-hand side. So I have negative 2y equals negative x plus 3. And then I'll divide each term by negative 2. That gives me y equals negative x divided by negative 2 would be x divided by 2, or you can write it as 1/2 x. And then this would be negative 3 over 2. Not really necessary to know that part of it, but it is there. My m value, then, my slope, is 1/2. So if my slope for this equation is 1/2, then the slope that's perpendicular, I'll just write imperp, right, perpendicular, would be the reciprocal. So the reciprocal of 1/2 is 2, and then the negation, so it's negative 2. So the negative reciprocal of 1/2 is negative 2. And then I have my point, so here's my slope, and here's my points. This time I'll use y minus y1 equals m times x minus x1. My y1 value I'm given is 1. My slope that I just found is negative 2. The x value I'm given is negative 3, so minus a negative 3. And I'll clean it up, right? So we're going to clean up this equation. So the first thing that I'll do is I will multiply through the negative 2. So I have negative 2x. This is minus negatives. This is positive 3 on the inside times the negative 2 on the outside to give me a negative 6. And then if I add my 1, my equation will be y equals negative 2x minus 5. And this is my solution then for a perpendicular line. You could always graph this. I didn't mention it in the last problem, but you could have on the last problem as well. You could graph them, right? I've got this form and I've got this form right here, and if I graph them, they should reasonably look like they're forming a 90-degree angle. Same thing over here. If I graphed this one and I graphed this one, they should seem parallel on the graph, right? It should be a reasonable solution when you're looking at it. And if it isn't, right, if you see them intersecting on this one, or you see these, like not intersecting or intersecting in a very not 90-degree angle, it should be a red flag that maybe there was something wrong. All right, the last example, number 10, talks about taking a perpendicular line to the line x equals 7. Here's the kicker, x equals 7. That's a vertical line, right? So, what is perpendicular to a vertical line? Yeah, it's a horizontal line. So I need to find the horizontal line that is through this point, 1, 2. Okay, so horizontal line has an equation y equals, and the y value in that ordered pair point is 2. And if you were to graph these to sort of verify that it makes sense what you just, found, you can do that too, right? So you can't use your calculator to graph x equals 7, like that's not a thing, but you could graph it yourself. X equals 7 is somewhere, it's a vertical line over here, right? Here's x equals 7. And we'll mark it on there, 7. And I have y equals 2, and y equals 2 would be a line, say, somewhere like that. And yeah, vertical lines and horizontal lines definitely form that 90-degree angle that we're talking about, and it is through the point 1, 2.